Hello, I'm Dr. Levon Hayrapetyan, a business professor at Houston Christian University. In this video tutorial, I will demonstrate how to sketch a graph of a function in Microsoft Excel. A commonly used method of sketching a graph is to select several values for x, then calculate the corresponding values of y, plot those points, and connect them with a smooth line. That's exactly what we are about to do by using Microsoft Excel. So let's start. Here, I'm going to demonstrate how to create or sketch a graph of function of y equals to a times x minus m raised to the n plus c. So in order to understand the meaning of a, m, n, and c, here I prepared several examples. For example, if when a is 1, m is 0, n is 2, and c is 0, it's basically y equals to x squared. When I keep the same values but replace a with negative 1, so it will become y equals to negative x squared. So here a is 1, m is 0, n is 2, which is the exponent, the power, and then c is 3. So this is the graph of x squared plus 3. Basically, the meaning of m is by how many units the graph will be shifted along x-axis. C is the value which describes by how many units graph will be shifted along y-axis. N is the exponent. So when we have 2, it's quadratic function, for 3, and so on. And A, which is the coefficient, describes the scale. So if A is 1, like in this case, it will be just x squared. So if I put a 2 in here, it will be 2x squared, which means the graph of x squared will be kind of compressed and it will become taller. All right, let's start sketching the graph. The first step is to select or generate some values for variable x, and this is this yellow range I designated for values of 5. So for x. So I will start with 5 and with negative 5. Let me put negative 5 in here. And I will create numbers or select numbers from negative 5 to positive 5 with the interval of 0.2. So the next one will be negative 4.8. The next will be negative 4.6. And so on. Now, and so on, it does not mean that I'm going to enter all these numbers in one number at a time separately. Now, we will use the nice feature of Excel when I select these two numbers. So Excel already figures out what's the relationship between these two numbers. And then when I drag down, which means copying it, it will generate numbers with the same property. And as you can see, we generated number, and each number is 0.2 more than the previous one. 0.2 more than the previous one. So these are values for x. Now, in this cell, I have to generate corresponding values of y, which means here I have to implement this formula. Here I designated some cells for A, M, N, and C, and as initial value, I selected 1 for A, 0 for M, 2 for N, and 0 for C. So now let me implement this in Excel. It will be equal. Each formula in Excel starts with this equal sign, then A, and this is the value of A, times x. The value of x is the content of this cell, minus m, and the value of m is in here, raised to, and that's the symbol like caret, which is control, which is shift 6, raised to the n, which is in here, and plus C, which is in here. So this is basically here, I select it in such a way, as you can see, these are the same course as in here, which means currently I am creating or sketching a graph of this function, y equals to x squared. So I calculate the value of only for the first x. So I have to do that for all x's. Now, obviously, I'm not going to do that individually for each of them. I will use another feature of Excel to copy down. But in order to copy down, first, I have to make sure that for each axis, I will use the same A, M, N, and C. And in order to do that, Excel has a nice feature called absolute addresses, and I'll make these addresses absolute. E4, E5, E6, and E7. These are the cells where my A, M, N, and C are saved. If you don't know about this, that's fine. Just follow me and see the results. But if you are interested, you can just go and Google or check YouTube videos about absolute versus relative addresses in Excel. So now I will hit enter, and now I will copy this formula down, and we calculated all of them. Now, if we want to check the formula here, the formula is E3, which is A times A8. A8 is the value of this cell below the 4, and so on. Now, when we have the values of X and the corresponding values of Y, we can sketch the graph. In order to do that, we'll select this entire range of X's and Y's. Then we will go to Insert tab, and then we'll select, and in the chart menu, we'll select Scatter Chart. And we'll select, for example, let me just slightly format this so it will look nicer. So this is the graph of this function, when A is 1, N is 0, N is 2, and C is 0. More specifically, this is the graph of function y equals to x squared. And as you know, this is the parabola. Now, what happens if I change this 1 to negative 1? So the sign of this coefficient A defines the direction of the parabola. When A is positive, the parabola opens up. When it's negative, it opens down. So see what happens. Now this is the graph of y equals to negative x squared. Let's go back to original x squared and play with this graph. So what happens if I change M to, let's start with C. If I change C to 5. So this is graph. C defines the units, how many units the graph of the function will be shifted along y-axis. 5 means it will be shifted by 5 units up because it's positive. Look at the graph, and you can see it was shifted 5 units up. If I use negative 5, it will be shifted along y-axis 5 units left. Now let me go back to original x squared and play with the value of M. So M specifies by how many units the graph of function will be shifted along x-axis. So let's put here M is 1, and you can see that the graph was shifted by 1 unit. Now it starts right here. Don't pay attention on this because we didn't generate values for more than 5. That's why this part is missing, but this is this parabola. If I do negative 1, it will be shifted left by 1 unit. Let me go to 0, back to 0. This is y equals to x squared. So let's see what happens when I change the sign, the value of n. N is this power or exponent. So when n is 2, it's quadratic function. What happens if I'll make this 3? So now this is the graph of the function of x squared. If I put -1 in here, it will be graph of function of negative x squared. And so on. Now let me change this to 4. So this is the graph of function of x to the 4. If I make it 5, graph, no, okay, let's make it 6. Graph of function y equals to x to the 6. So as you can see, when the exponent is an even number, 2, 4, or 6, so it's a parabola. Just the higher the number or exponent, so you'll have more kind of flat bottom of this part of this parabola. So we learned how to easily sketch a graph using Excel. The same way we can sketch any graph. The only thing which we have to do is when we calculate the value of function here, we should to calculate the function, whichever graph we want to describe. This concludes my short video. Have a nice day.